Hello out there. My name is Ted Neward, and we are here on the FatCloud Cassandra Riak NoSQL Software Summit, virtually speaking. My name is Ted Neward, and I am your moderator for the day. We have a collection of different technology companies, the aforementioned three, FatCloud, Cassandra, and Riak. And we have a customer from each of those companies here to speak today a little bit about NoSQL and some of their experiences with, as well as for the companies in question, some of the technical issues with. If you're just joining the webinar, the audio and the video are not coming out real great. Welcome to the wonderful world of internet technology. One suggestion would be to log out and log back in again, give the webinar a chance to reset itself. If you have any questions for any of our distinguished panelists, go ahead and use the chat over here on the right-hand side. This is on my machine here. Just type your message and type it such that either the organizers, presenters, or all can see it, and we'll go ahead and feed those questions to our panelists as we go. Just to kind of set the mood, though, let's talk a little bit about what NoSQL means and what it doesn't mean. In particular, my personal opinion is that the term NoSQL is a terrible term. The fact that we're later trying to sort of revise the term NoSQL to mean not only SQL is a bit of a misnomer. The fact of the matter is that anytime you try to categorize something as not something else, you tend to lead to a fairly how shall we say, inconclusive description. So, for example, if we say that SQL and then we have not SQL, well, technically rainbows and unicorns are also not SQL, which is not particularly helpful. The NoSQL movement, though, does address a particularly important issue, which is to say that not everything can be stored successfully inside of a relational database. The NoSQL movement, in fact, looks to address what one guy, a gentleman by the name of, and I just lost his name. Wow, you gotta love it when your mind goes blank on you like that. Anyway, Julian Brewer, that's who it was a researcher at the University of California at Berkeley, if I'm not mistaken, and in 2000 he wrote a paper entitled The Theorem, which CAP is an acronym standing for Consistency, Availability, and Partitioning. Now, kind of like as a consultant, when you meet with your customers, you say better, faster, cheaper, pick two. The CAP theorem says consistency, availability, and partitioning. Pick two. You get two of those. And historically, the relational space has always chosen consistency and availability and sacrificed the ability to partition. Many, if not most, of your NoSQLs are choosing two others besides consistency and availability. Some of them will choose consistency and partitioning. Some of them will choose availability and partitioning. Some of them consistency and availability, just like the relational database does. The point is that today what we're starting to see is an explosion of different ways in which to store your data, built around, for example, different forms, different models of data. So, for example, we have the Cassandra guys who are going after a slightly different shape than the traditional table approach. They're going for more of a column-oriented approach, which allows for some flexibility. There are a number of different approaches. Mongo and Couch, for example, talk about document-oriented and so on and so forth. I'm going to let the individual groups talk about the particular data models and why they chose what they did. The point is that the NoSQLs typically give us three things to think about. The shape of the data, is it a document, is it a graph, is it a column or some flexible set of columns? Is it schema-less? The NoSQLs have sort of approached this idea of SQL-less or schema-less data, the idea that we don't have to know up front exactly what our data model will be, which draws an interesting analogy between the statically typed programming languages, the relational database, the dynamically typed programming languages, and some of these schema-less databases, which have both pros and cons associated with them. Very similar in many respects to the pros and cons associated with static and dynamic programming languages. And the last thing, we have shape, schema-less, and then scale. Because so many of the NoSQLs have opted to optimize in terms of partitioning, most of the NoSQL, their original claim to fame was in the realm of scale. So, for example, you have various riffs. One of my favorites, for example, is if you Google on the phrase "MongoDB is web scale," it's an audio rendition of what is apparently a newsgroup forum. Well, let's just call it a newsgroup forum chat, which involves a lot of not suitable for work kinds of words. So be prepared for that if you look for it. It's quite funny, but it does highlight the fact that in many cases people were choosing the NoSQL specifically over issues of scale. So again, shape, schemaless, and scale, that's where a lot of people come in terms of coming into the NoSQL space. Now again, if you're just joining us for the webinar, if your audio and video is not great, you can log out and log back in again. If you have any questions for myself or any of the other panelists who I'm going to ask to introduce themselves in about 30 seconds, go ahead and fire it up here into the chat. And for example, I will send out a chat message right now saying, panelists, it's time to introduce yourselves. Like so. So in the go to webinar control panel, there should be a chat message now that should be addressed to the entire audience. Again, you can either choose to address it to the entire audience if you want to make your question heard to the entire audience, or you can set it to the organizers and panelists, or just the current presenter. And again, you can send chat messages to each other, but unless you know each other, I probably wouldn't do that. Okay. So, what I'm going to do, let's start with Justin. Why don't you tell us a little bit about who you are and what you do for FatCloud?
Hi there. I'm Justin Weiler. I'm the CTO of FatCloud, and I help with the general architecture and some of the implementation of our cloud computing platform. Okay.
And Tinder, my understanding is that you're currently using FatCloud at your place of business. Can you tell us a little bit about who you are and what you guys do?
Yeah, hi, this is Atinder, and I'm Chief Architect for Move Music platform, and we are using FatCloud FatDB for last 3 years now.
Cool deal. Patrick, you work for DataStax, is that correct? No, we may have lost Patrick. But fortunately, we do have Michael from Barracuda Networks, if I'm not mistaken. You guys are using Cassandra, correct?
Yep. We've used Cassandra for 2 years. Pretty active in the community. And it's been really, really useful for us in scaling our business to the next level and allow us to track quite a bit more data than we were in the past.
Okay. Now for the other Justin, Justin Shea, who, as I understand it, works for Riak. Is that correct?
Well, I work for Basho. That's the company that is at the center of Riak. Riak is the open source database in question, and Basho is the company behind it. I'm the CTO here, which mostly just means I try to solve more problems than I cause.
Are you successful? Or do you create more problems than you solve?
That really depends on what time scale you choose to look at, I think.
And Anthony, my understanding is that you guys are currently using Riak at your place of business. Is that correct?
Yeah, my name is Anthony Molinero. I work at a company called OpenX. We've actually been using NoSQL databases for about 4 years. We've used Cassandra. We currently are using a lot of Riak, and have also investigated CouchDB and MongoDB and Redis and quite a few others.
Okay, so let me go ahead and start with that. You know, Anthony, you said you looked at a number of the different NoSQLs and you ended up with Riak. What specifically were you? Oh, wait! Before I ask this question, Patrick has rejoined us from DataStax. Patrick, you want 30 seconds to introduce yourself?
Yeah, my mic wasn't working the way I expected to. Yeah, so I'm Patrick McFadden. I always say I'm a community member first, DataStax, employee second. I've been using Cassandra for years and a lot of other NoSQL databases. But my job is I work with community, I work with customers of DataStax, but just implementation, and it's usually just application level implementation.
Okay, cool. So, Anthony, you mentioned that you had evaluated a number of different NoSQL implementations. You mentioned Mongo, you mentioned Couch, you ended up with Riak. What specifically were you looking at when you were doing some of these evaluations? And I guess let me start it with the question, why not a traditional relational database?
Before OpenX, I worked at Yahoo and had many years spent a lot of time working with these sort of high volume, high throughput systems, and we always tended to run into problems with relational databases. So at Yahoo, we had sort of built a lot of in-memory, sort of hand-created databases that were pretty much just key value stores, and sort of got in the habit of doing all of our serving from those stores because pretty much you didn't really ever have issues with them. They were as fast as they really needed to be, and a lot of times when you're actually doing, serving, and in my case, serving ads, it's not like you need a lot of the relationship type of things. Really what you need is I need this particular piece of information right now at this time. You know what the piece of information is, so all of the bells and whistles that you get with the relational database system were just unnecessary. So on coming to OpenX, immediately I started looking into the state of the NoSQL world at that point. I mean, this is 2009, so there was mostly a lot of things being started out. I went to a meetup in San Francisco and actually heard a lot of speakers come and talk about their different systems. The result of that meeting is I actually chose Cassandra for OpenX. And we actually used Cassandra in production for, well, up till now. And when we reached we essentially reached a point where it really wasn't scaling with us. We were having some issues with it. And I reinvestigated what was out there. Came across Riak, and they seemed to solve a lot of the issues that we had. So we tried that out. And after some initial prototypes, it was working really well. And earlier this year, we actually transitioned our largest system off of Cassandra and onto Riak.
Ted, I think you've muted yourself.
Yeah, I couldn't hear you.
Yeah, I gotta love technology. What I was saying is, Michael, obviously your experience with Cassandra is a little bit different. Anthony, they started with Cassandra, moved to Riak. My understanding is you're still using Cassandra at Barracuda. What was your experience with Cassandra, and why did you choose it over relational database or a different NoSQL?
We were primarily a MySQL shop. We've got tons of MySQL instances all over the place. We have a lot of experience with MySQL and getting MySQL to quote scale. I personally have found that the Cassandra community is really awesome, and they're able to really, help everyone sort of on their free time, just out of the goodness of their heart, to really make your application scale to new levels. And it's not just me, there's all these different companies that we just had at the Cassandra Summit once a year meetup, and really hearing all these great use cases with Cassandra and how people are able to shape, graph databases and sort of morph relational databases on top of NoSQL solutions, all backed by Cassandra. It's pretty powerful stuff. And more importantly, we have metrics that actually prove that it's taken us, for maybe matters of 8 to 10 to 15 minutes to deal with something down to 3. Application latency is down from 5 milliseconds down to 2. All across the board, we have performance increases. And from an operational standpoint, we've really got things humming along. So we're a really happy customer.
That's pretty cool. Those are good reasons. I approve. Atinder, you're using FatCloud, which I will admit is the newest of the three, at least to me. I only learned about FatCloud a couple of months ago. So I'd be curious as to, what got you to where you are now in terms of using FatCloud and their products.
Few things there. Basically, when we started looking at, again, like Anthony, we started building up or architecting Move Music around 2009. And we are Windows Microsoft .NET shop, so there is not much available related to that, and there was not much of open sources other than Cassandra and few were available. So when we started, we had less funding to start with, and we wanted some cheap solution. We started looking into even using, not going to SQL Server for sure, we were looking into Postgre and all that to see if that can work out, and we find FatCloud, FatDB. We saw some benefits there comparing to other, and with the FatCloud, we can build our own add-ins, business add-ins, deploy on the server where the data is residing. So data can be anywhere. It doesn't need to be on the server where your web server is. So that was one of the major benefits we saw. Instead of putting all business logic on the web layer, we started putting major logic on the database server itself where the data is stored. So that there is not much of data transfer between server to server. Only we need to send whatever we need to send after the final computation. Then obviously, when we started, there were some issues in between. We faced issues. Like when we started, the target was that we may be getting 200,000 customers in first year, and instead of that, we hit 800,000 or 900,000 customers.
It's a good problem to have.
Yeah, so and issue with initially we had was that our business logics were on the correct place, but data could be on any of the server groups. That means still we were still hitting the issue which we will hit if the business logic was on the web server while the data was somewhere else. So FatCloud team solved that for us by providing us the locality key. Now we can provide the locality key and tell where the data is residing, go there and use the business logic there and get us whatever we can get. And that's solved a lot of problem for us. And since then, basically since beginning, we are still growing. We already crossed, I think, 1.6 million customers and still going good. In between, we had to scale the server. Basically, we had to scale, so we added more servers without downtime. Till now, whenever we have deployed, we have gone with the rolling deployment, no downtime there. We didn't have any issues.
This is good. This is good.
Yeah.
So one thing I'm sort of curious, and Atinder, Michael, Anthony, this is to any of the three of you. One of the things that I've run across with people coming up and talking about some of the NoSQLs, they hear this notion of we're dropping C or we're losing a certain amount of C consistency, and of course the keyword there is transactions. Everybody's concerned that we're going to lose transactional integrity. Oh my gosh, my data is going to be lost, etc. In terms of your guys' experience, have you found that eventual consistency still works? Did this create a problem? Did you build your own consistency model on top of these guys? Anthony, what was your experience?
So the largest instance of Riak that we use, luckily enough, and with the one we're using Cassandra on, we don't really care about small amounts of data loss. This is keeping information about users and the ads that they've seen, or information related to users. So we have many billions of keys and terabytes of data spread across hundreds of machines in our 5 colos. So it's a lot of data, and you lose a little bit, it really just makes things not too bad. But we did have to deal with sort of simultaneous updates in the Riak model, which meant sort of dealing with sort of siblings and merging of data, which was challenging but not really extremely difficult. So I guess we sidestepped the consistency in that, like, for any particular read, I don't really care about the consistency of the read. If it's eventually consistent, that's totally fine. We do have another use case where it's actually more of a real replacement of a SQL system. And in that case, there's more worry around consistency. But luckily, if you just tune your sort of read and write quorum parameters, you can usually get to a level of consistency that's acceptable. And again, you sort of give up some of it and say, well, sometimes if someone sees a screen, the data might be slightly out of date. They may be looking at a slightly older version of it. But if they refresh, they'll just see the new one. So I think the main thing is to sort of realize that you're giving up some amount of consistency in the experience, but what you're gaining is a scalability and just speed.
Mm-hmm. Yeah, speaking of speed, Michael, Cassandra has, at least the last time I looked, one of the things that Cassandra has offered as one of its wins is that supposedly they do writes faster than reads. Is that one of the things? I mean, is the problem you guys were looking at was the speed of I/O in and out particularly important, or was that just kind of a
so there's a few things here I'd address in your question. First off, reads is now about equal in Cassandra to writes as of 1.1, and in 1.2 it's even better. And in 2.0, to answer your original question sort of about eventual consistency, there's a new feature based on Paxos called compare and set, which will actually give you atomic updates across a distributed database without the need for Zookeeper or some type of distributed lock. So it's super cool, and obviously you're going to lose performance on those writes and reads where that type of consistency is needed, but as Anthony had mentioned, it's not necessary in most people's logic across the entire spectrum. There's probably only a couple of use cases where maybe it's really useful, but it's pretty powerful that you can just change the consistency level, and bam, now you've got some sort of relational, consistency going on there. Additionally, in terms of the read-write load that we have, we're about 50-50. We still front-end memcache for sort of like really, really high caching stuff just because there's no need for it to hit our cluster. I think that answered all of your questions. Sorry.
That's okay. If you want to answer questions I didn't ask, that's always cool too. Yeah, it's in there. When we hear some of the discussions around the NoSQLs, Riak and Cassandra, been out for a few years. You hear some of the discussions around speed, performance, etc. And to be blunt, the .NET platform is not always recognized for its performance. And I say that as somebody who's written C# and F# books, right? So I have nothing but love for the .NET platform. What's been your experience, just in terms of your performance needs and your experience with FatCloud?
As such, we don't. Systems are working fine. They're performing well. Response time is pretty fast, and the resource utilization, CPU-wise, and all that, they are pretty low, like 2%, 3%, not high. And we are like sub-second response times, going to handsets and all that. And on top of it, that we don't need to put anything for consistency or even memcache or anything because it's built into FatCloud itself. And FatCloud has a feature called delay writes. So we have some of the tables or contacts, we call it, in FatCloud, which are hit pretty quickly, like whenever a user is modifying any library or anything. So we have set the delay writes on it. That way, it's not writing that often. It's writing periodically, and that way, we are not hitting the hard drives or anything during the writes. The response time is pretty good, and FatCloud got built-in cache on top of data storage. So basically, whatever you pull it out, it goes in a cache. So next time you pull it, unless cache expires, it will return from the cache whatever was modified.
Mm. Just out of curiosity, how many of you guys are using a caching system on top of the data store? I know at Tinder you mentioned it. I think, Michael, did you mention, are you guys using a cache as well as Cassandra? I thought one of.
Yeah, I think Michael said we are not using any caching on top of it.
Yeah, we do front end some of our logic with memcache.
Okay. Anthony, do you guys cache in front?
No, we don't.
Okay. All right.
Ironically, we had an application issue. We just were going full time, and it turned out that memcache was what crashed, and it was in a hung state. And so we're now probably going to be ripping out all the memcache and going straight to Cassandra. So it was a little frustrating because my goal was to reduced that read load, and it actually bit me in the butt. So.
Right. So
yeah, Ted, I was going to mention on the transaction stuff, just in general.
Go ahead.
I mean, it doesn't matter. I mean, if you're even using relational databases, the transactions I think are kind of candy right now for someone who can use them. You usually wind up using them all the time when they don't need to. There was a great paper a few years back called "Your Coffee Shop Doesn't Use a Two-Phase Commit," and it really comes down to when you go to, say, Starbucks to get a coffee, you don't sit at the cash register and then order your coffee, and then they go make your coffee. They come back, and then if it's not right, then they go over, dump out the coffee, then give back your money, and then start the transaction all over again. I mean, that's the commit rollback. Does your coffee shop do that? No way. You walk up to the cash register, you give your order, you give me your money, and you go to the side. You're queued off. That transaction is finished according to the cash register. But then if your coffee comes back wrong, then it's up to the barista or whoever's behind the counter there to deal with it. It doesn't hold up the whole line. And could you imagine if Starbucks, that was their model, is that every transaction has to be completed every single time you walk up to a cash register? And if you think about it from an applications side, that makes a lot of sense too. I mean, we've gotten used to using transactions, but they are expensive and they cause bottlenecks. And I think I work a lot with people just building applications that once we get into it, you really don't need a transaction.
Mm-hmm. Mm-hmm. Well, and certainly,
if I can just add.
Go ahead.
If I can just add to what Patrick was saying, because I completely agree, but quite often said in response, well, that's fine for your little thing or Starbucks or whatever, but money and commerce and all these other things, that's where it matters. And the funny thing is that banks have been using eventual consistency for a lot longer than we've had computers, right? And this this notion of having to hold the world still while you do everything and have everything be frozen to take action is also one that doesn't work for the most important high-value transactions in the not database sense, but actually moving money around the world. None of those use transactions or locks on things. That's not actually how people move money around the world either. It's one trade-off for one part of building a computer system, but it's certainly not the only one that can protect you.
And the real need is to make sure that you store what's happening with consistency, meaning that whenever something happens, you store it reliably. That's the real port. Whenever you do a transaction at a bank, you don't want that to get lost, especially if you're putting money in the bank. But it doesn't mean that it's going to be 100% consistent right now. And I think if you look at how banks work now, I think you can pretty much see that's the way it works. Money shows up the next day or something like that. But I want to make sure that money that I put in there, that does eventually show up.
Right. Banks, just like the web. Go ahead.
I think anyone who's ever been in college knows exactly this, that you can write a check without there being any money in your account, knowing that by the time the check actually clears, you will have gotten paid. This is eventual consistency, left and right.
The payday float. Yeah, it's a great computer science algorithm.
Exactly.
Well,
So,
go ahead.
I'm sorry. Go ahead, Justin.
I was just saying that banking system, just like the web in general, is making an explicit availability trade-off, right? I mean, there are no CA distributed systems. There's no such thing. And so you have to give up that notion of a global transaction to have a system that's present in the real world that way, to be available even when arbitrary other parts aren't working. It's that simple.
Yeah. Now, one of the other things, having sort of beaten the transaction story to death just a little bit, one of the things that frequently also comes up alongside some of the discussions around transactions and consistency is the notion of schema, right? The idea that schema is necessary in order to be able to ensure data consistency, right? That we can make sure that only the right kinds of data are going into the database and that they are validated by a certain amount of schema rules and so on and so forth. I'm curious, and Tinder, we'll start with you. what's been your experience in terms of the need for consistency on the data side? In other words, has going schema-less really caused a problem for you, or is it not a big deal?
It's not a big deal, and consistency, again, it's built into FatCloud, so we don't worry about that. Obviously, not all servers in a group are in sync. They get out of sync, and FatCloud, FatDB take care of it. And on top of it, like as such, Move Music do not have or does not have any website where user interacts right now. It's the handset mobile app. So the Move Music is unlimited subscription-based music service. So user add tracks to library, remove it, playlist, and all that. So for user, it's obviously they have the database on the handset too, so they don't feel it if there is any difference. We have a duplicate copy sitting on the handset of their library, and while we are syncing in the cloud, and which can be used in case handset they clean the handset and they re-download and all that.
Mm-hmm. Anthony, Michael, any transaction issues you guys have run? Or I'm sorry, not transactions. See, I got transactions on the brain. Any schema-less issues that you guys have run into in terms of implementing Riak and/or Cassandra?
Well, what I'd like to say is I think that the way we've addressed it is we try to do validation at a higher level than the database itself. In these systems where you're essentially looking at a key value store, the data is pretty much a blob of data. I mean, sure, in a column-oriented store you might have multiple blobs, but for the most part, as far as the applications are concerned as a blob of data, validation needs to happen at a higher level. And really what you have in most of these, multi-layer architectures these days anyway is the information the user is dealing with is very divorced from the actual underlying data source itself. And so you can do a whole lot of validation of these, documents as you were before they actually then just get serialized into some blob and stuck into the database system. So that's how I'd say we've addressed all of those issues is you do your validation sort of way up in the stack, make sure the data is consistent, as close to the user who can actually deal with problems with the data as possible. And then by the time you get to the actual storage layer, you're pretty much just dealing with blob of data.
Mm-hmm.
I actually sort of disagree there, just because I write a lot of bugs, and when bugs happen in my application, the database saves my butt when I start inserting incorrect data, especially in forms of timestamps or what have you, So there's sort of a slight change going on in the Cassandra community right now between Thrift and CQL. And CQL looks a lot like SQL, makes it fairly approachable, but it also really enforces a schema, and you do have to give some thought ahead. And while some may not think that that's the correct way to go, you can still obviously turn all that off. You can still just have everything just be byte arrays and not be validated. I think it's actually a good thing because I think forcing people to really think about their data model and figuring out if they're going to screw up going forward. And then, obviously trying to catch those mistakes later on when you introduce that bug that you didn't mean to, and write a bunch of stuff into your data that you didn't realize was going to happen. I think that's a pretty powerful proposition if it's not hurting your write performance.
Let me ask you this, and I'm going to point this one straight at Patrick since you represent DataStax and Cassandra. One of the things that I've run into, at least, when talking to... I'm sorry?
I said I'm ready. Go ahead.
Okay. One of the things that I've run into when I'm talking to people about, some of the various NoSQL technologies, consulting and whatnot, is the desire to try to do traditional relational things on top of something that isn't a relational store. And one of the things that I've run across is people have looked at Cassandra and CQL in particular and said, oh, look, it's just like an RDBMS. I can treat it the same way. I can, continue to have my, foreign key relationships, et cetera, et cetera. Have you guys run across a lot of people doing this, or is it just the people talking to me?
No, I think it's a bridge that we're all trying to cross. I mean, I also work a lot with Solar. I work with Hadoop, and anytime I talk to relational database administrators or relational database developers, which I used to be an Oracle DBA. I mean, you think about your data first. You know, you create your relations, you create your normal forms. That's the way we did it. And so if I have a lot of data, I'm going to make sure that it's generally usable, because then I can do different kinds of joins. But we've shifted our thinking quite a bit. I mean, if you use Cassandra, or even if you use Solr, if you use memcache, you're thinking about your application at that point. So it's a top-down anymore. And so whenever I hear someone say, well, how can I copy my database, my MySQL or Oracle database, into, say, Cassandra? Like, well, stop. You just thought about this completely incorrectly, because it's not a copy and paste. You're not taking it to somewhere where it's going to be happier. It's that thinking that we have to shift. I spend a lot of my time just talking about data modeling and application development, because that's where things like this live. We all got here. I mean, back in, say, early 2000s, 2001, 2002, when I was first starting to work on, you know, more web acceleration and web performance, the database was the problem, and we're starting to fix that now. So, you know, I think that's the shift in any kind of development, no matter what technology you're using now, is really thinking about the application.
Mm-hmm. Justin, working for FatCloud, you know, obviously the .NET space, you walk into any Microsoft shop, and the first thing that, you know, and again, most .NET shops are Microsoft shops, the first thing that's going to come to mind in terms of data storage is the server. You know, are you finding that the Microsoft community is more reluctant to let go of their relational database, or are they embracing the NoSQL just as quickly as what we see in the Java and Ruby and JavaScript communities?
I think the difference is actually quite striking. You know, most of the outreach that we've done really involves educating folks on what NoSQL is. There seems to be a tremendous divide amongst folks. You either get them in one of two camps. One, they have no idea what NoSQL is and why you would even want to use it. And the other is that they've read up a bit on the techniques. They've done large-scale applications. They understand the challenges involved in you know, making something scalable and responsive. And those tend to be immediately productive conversations. But you know, once you can get past the initial education part and identify somebody whose domain requires you know, extreme scalability and responsiveness and the ability to pivot your architecture when business needs change, then you can start having you know, fruitful architecture discussions and talk about the different ways of solving typical problems. And you know, that's usually I hope to get to that point in the conversation.
Out of curiosity, Patrick, DataStax, Justin, Basho, have you guys gotten much uptake from the .NET community, or are you guys still Java, Ruby, etc. space?
You can go ahead, Justin.
All right. So we don't currently support Riak itself running the server on a .NET environment, and that's simply been a cost-benefit analysis that we've done over a few times, right? We've looked at it, right? We are supported on the Microsoft Azure cloud because, you know, we were part of their program to run things in their own other operating systems. And so, you know, we've gone multiple times with customers and community and so on, trying to figure out if it's worth, you know, because it's not just making our code run, it's changing our, you know, it's adding a lot of interesting things to our pretty significant testing infrastructure and building a new platform expertise. So server side, it's not a we don't like it or anything like that. It's simply about measuring cost. And for us personally, it hasn't been worth it. Now that's the server side. We do have a number of places that are polyglot with regard to their server platform and that run a bunch of applications on .NET. And there are pretty high quality community developed client libraries that work against Riak from .NET. and so on. So there are .NET applications that use Riak as their database, right? And that works pretty darn well. That's a separate issue than running the actual Riak database server proper on Windows, right? Those aren't exactly the same thing. So on the one hand, there's some uptake of people that are in the .NET community using Riak in that sense, right? So they can write C# programs, they can run their whole application in its existing environment. And since most people don't want to run much other than their database on their database servers, you know, a smart shop doesn't actually care what operating system is running on a machine that's only running one program if that thing is demanding certain requirements. So that's working out reasonably well for us currently as a choice. But again, it's not a religious sort of thing. It's just the way the cost benefit has added up all along.
Patrick, did you want to jump in there?
And for Cassandra, for Cassandra, we're from DataStax, we have two main drivers that we support right now, and we're working on more. But that's of course our Java driver, but we also have a C# driver, which is ADO.NET and Link compatible. So we really do have a lot of C# developers. We're deployed in a lot of large enterprises, and Cassandra does run on Windows. We have a lot of large-scale Windows deployments with Cassandra. So I think that community, I just did a talk yesterday on our driver, and it was mostly .NET developers. And so we are definitely embracing the .NET crowd for sure, because it's where there's a lot of development. Let's face it, I think there was some statistic like 50% of the servers running in data centers are running Windows. So we're on that, and because that's where our users are.
So how many of you guys are volunteering to have a Windows 8 version out somewhere in the, no, I'm teasing. I'm totally teasing. Totally making that up. Question sort of back to the customers, the users. One of the things that frequently comes up is questions about doing reporting, right? This is a big deal for a lot of business types. I want to know, I want the McDonald's style dashboard, right? 15 million served. I want to know details about my customer base. And of course, the advantage of the traditional relational database has always been I can pick up an off-the-shelf reporting tool like Crystal Reports or maybe Crystal Reports, and give that to my business analysts or my management and say, here, you can create your own report against the database. And obviously, when we start getting away from that SQL relational data model, that no longer becomes really a possibility. Curious to know, and I'll start with you, Michael, I'm curious to know what, if any, reporting requirements your applications had, and if there was, how did you deal with it?
There's Hadoop support built into vanilla Cassandra, so you can use it as both the input method into Hadoop and an export method. So in terms of something built in off the shelf, as a company, we don't actually tend to buy those at Barracuda. So probably not the best to answer there. But in terms of getting at all of your data and iterating through it and doing powerful analytics with Pig and Hadoop, and then not needing to remove that data and stick it somewhere else, but just have it stay in your database and iterate over it, that's how we've solved that problem.
Anthony?
We've not had to really address this problem because the main data that we look at, we don't really...
Whoa.
That's okay.
Sorry, I just want to point out, I just saw that Talon and Jaspersoft also have support, I guess, for Cassandra.
Okay. So you were saying, Anthony, that you don't really, this isn't a problem for you guys?
Yeah, our sort of reporting and analytics system is not run off of Riak. Mostly it's our serve time data, and in terms of reports, we don't really require a lot of reports. We gather information about when actions occur, and then we put those into other systems, which actually give us, those go onto Hadoop and then get put into a data warehouse, which in the past was very large MySQL, but I think might be moving to Vertica or something like that. So sort of a completely different system, different requirements. and that's not really the side of the business that I am heavily involved with. So.
Okay. Tinder reporting, has this been an issue for you guys?
Yeah, for, currently the version we are using from FatCloud doesn't have a built-in reporting feature. So we had a workaround where we use FatCloud teams provided a few assemblies, and we have the wrappers written or the work queue jobs written, which goes and pull the data and process and generates the report out of it. But last I heard that now they have some SQL Server connectivity built into the system where you can import or export data from the FatDB into SQL and then generate better reports out of it. So we are not using that version yet.
So I'm kind of curious, and maybe Justin, Patrick, and Justin, are you guys, in terms of being a NoSQL vendor, are you guys seeing requirements around reporting, or is that a thing of the 90s and we should all just, get over it?
One of the things I want to sort of mention, I didn't chime in the kind of the transaction discussion, is that folks don't want to give up SQL for good reason. SQL Server is fantastic at doing the things that it does well. And a lot of times folks have legacy applications that, they have a lot invested in SQL Server, personnel, code, et cetera, et cetera. So we found a lot of response, a lot of interest was generated by really not, scorched earth replacing SQL Server altogether, but by enhancing SQL Server by really removing a lot of the tasks and data that can be NoSQLized and allowing SQL to do what it does best, including reporting. And that has resonated more than a lot of the other aspects of our platform.
Yeah, I would agree with that. I mean, I think that the bigger and more interesting an enterprise's IT operations are, the more likely it is that they're going to be polyglot in their data management environment, even if they don't want to be, right? Even if they haven't thought through what's best for each element of their work. Just this is how enterprises end up growing. And so, you get, I think Anthony mentioned, you see Vertica in place for some kinds of, report generation. You see, things like Tableau and other things like that in some cases for an entirely different type of analysis. So, what we mostly try to do is focus at our core on the reasons people add Riak to what they're doing, right? Which really comes down to availability, scalability, operational ease around their critical data, right? Not their, everything they could possibly ever know about, but the data that if you stop being able to manage it, your business stops. And then try to make enough data querying and analysis capabilities that don't conflict with those goals. And then also, continuously working on improving partnerships with the companies that build things that have really complementary features. And so, we've got a few of those going, and we hope to see a few of them get more mature. But it's absolutely the case that for a lot of the, big data warehouse-like or even more interesting reporting environments, Riak will not be everything people imagine they could get out of their database for that. And, it's a gray area, right? We take partnerships in some places. We try to make things, more flexible and more, queryable when it doesn't conflict with, the things that are the whole reason we're here.
Patrick, any comments?
So on the DataStax, the DataStax side. I mean, of course, that's our stack, right? I mean, Cassandra is really our core, and of course, it's for good reason. I mean, it's where we started. But what we look at as reporting is a kind of a critical feature for our customers. For instance, eBay does most of their reporting using Cassandra, but also with our Hadoop implementation on top of it. So what we looked at it as is just an opportunity to use Cassandra in a different way. So instead of using HDFS, we use Cassandra's data layer. So you can take speed, take that data at speed, and then do MapReduce over it using Pig or Hive or what have you. So you can still get those analytic workloads. But we also put on Solar, and that's probably what's more typically used for exploratory analytics, because Solar is really fast indexing engine. It does facets and things like that, but it can scale up to terabytes, petabytes of data if you do it correctly. So I think it's one of the things that we've decided that as a company to really help address, and because data is not getting smaller and it's not getting slower, it just has to get there. So it's like I said, that's why we're called DataStax, because we try to layer things up. And I think when it comes to where customers are going, I don't think we're really going to have to predict that. It's hard to predict, because let's face it, I mean, I keep hearing that data is going to double every 2 years. What are we going to do with all this data? So I think we all have a big challenge in front of us.
Well, I think what we do with the data is very obvious. We immediately package it up and send it off to the NSA for analysis to figure out, no, we're not going to.
And that's why you should use an open source database, because we know where the backdoors are, because you can get clone and get the data. You can find out where all the code is.
Yeah, we'll not talk about the NSA's secret hardware channels that they've worked into every. Conspiracy theories can abound here. So, kind of one final question, and I'm gonna ask this of each of you directly. What's been your biggest disappointment? Because nothing is ever perfect. What's been your biggest disappointment, customers, in terms of the tool that you're using, and you not necessarily a flaw with the tool, but just I expected it to be all rainbows and unicorns, and it wasn't for this particular reason. What's been your biggest disappointment or challenge with the tool that you're using? And vendors, what's been your biggest struggle in terms of getting NoSQL adoption? And Anthony, I'll start with you. What's been the biggest struggle that you've run into?
I would guess I haven't yet seen any of the tools have a really good sort of out-of-the-box monitoring solution that integrates with sort of other systems that you might already have for monitoring. So we've usually had to build our own monitoring around the systems. And I can see that because, I mean, even our own systems monitoring is usually kind of at the bottom of the priority pile. But I'd say that's, I would guess probably across the board, I haven't really seen sort of good monitoring setups for any of the systems.
Okay. Cassandra?
We're not using FatCloud's built-in monitoring yet. We are using our open source services, basically. We are using two tools. One is forgot the name already. It's been so many days I looked into it. One for sure is for reporting purposes of basically that service read the logs and all that, and so that we can look into the logs from all the servers in one place. We're using Splunk for that. That's a really handy tool there. That's all. We're not using built-in performance monitoring from FatCloud yet. They have the built-in, but not to the extent what we wanted.
Okay. Michael?
I guess I'll speak to more operational issues. I think that Cassandra has met all of our needs there, but nothing's a silver bullet. And so obviously, I think there's this misunderstanding that I/O doesn't become an issue when you switch to a NoSQL solution. And so, well, now because I'm using, insert Riak or Mongo or Cassandra here, I can now throw millions of inserts at the same, sometimes more underpowered hardware than you were using before that couldn't even handle, a couple thousand transactions per second. I think that's probably the biggest misunderstanding. And when I first started doing it too, I did it. As an engineer, you look at this stuff and you start to forget the fundamental core things that you've taught and you've done your whole life. And so I guess the compactions in Cassandra can be a big pain. and thinking that the data is just going to flush out of memory to disk on a spinning 7200K drive is a joke.
Right.
So I think that's the biggest thing wasn't necessarily the code not doing the right thing, but misunderstanding of how to use the tool correctly. And there's also a little bit of a learning curve on understanding how to deploy Java in a environment. And I think once you get that though, and you have to understand that just like any other language, you need to know how to troubleshoot it and how to diagnose it, what a stack trace is, etc., and how to do it. It just becomes like anything else. And if that wasn't what you're used to before, it's going to bite you sooner rather than later.
Right. Right. Patrick, speaking as the vendor, what's been your biggest struggle in terms of customers looking at the various tools?
I mean, I'm sure everyone's got this problem. It's just that bridging the gap from where we were with relational to non-relational. And, I just recently did a talk on data modeling. That's all it was. I had 800 attendees. This is really a sore part of where we're trying to find adoption. I think they get that it's a cool technology or that it could work, but when you get down to it, it's like, how does it work for me? What's my model? And that's a real problem. I personally this is my mission. I'm trying to solve this, but I think this is the biggest problem we have right now.
Mm-hmm. Justin Shea, Riak, problems, adoption, etc.
Sure. First off, Anthony, let's talk later about monitoring. But I think part of it is what Patrick said, and I also see it as kind of the flip side of what Michael was saying in terms of this mythology that people get about when they do get the NoSQL hype and they expect magic. There's some of that, but I actually think that the big challenge for us is the flip side of that. What most of us see because of this bubble of people we talk to are either people that are happen to be reasonable and get it, or people that have fully bought that mythology. But the vast majority of people out there are on the opposite side of that, where all of this stuff is just weird and scary because it's different from what everyone gets taught how a database works, right? Because of the whole monoculture that took about a couple of decades before NoSQL, even though it wasn't like that before then. People got used to a bunch of things being very simply how all databases work. And anything other than that seems dangerous and scary. When in reality, well, sometimes it is, but sometimes you want to make other choices for a good reason. And I think it's really funny that programmers and software developers think that they make all these trade-offs all the time, right? When you choose your programming language, your framework, your operating system. But most of us got trained pretty heavily, if we started anytime in the past few decades, that you don't actually make a trade-off, even if you think you do, about your database. You pick one that looks the same, right? All DB2, Oracle, MySQL, etc., because that's the right way. And so getting people to start thinking that way about their database, the way that they think about every other part of their systems architecture, is, I think, the fundamental challenge here.
Mr. Weiler?
All of the above. I mean, everything that everybody's mentioned is, are the things that we struggle with on a daily basis. It's the bridging the educational gap is tough. It's really tough because folks just, we're at a point where folks are just starting to understand that there's a different way of doing things, and if they want to scale, they're going to have to start thinking in new terms, and getting folks to actually think in new terms is really challenging. Another aspect that sort of dovetails in with that is, especially for the Microsoft community, they're pretty demanding as far as their tooling goes. They want things as point and click as possible, which means wizards, everything is handled as completely as possible for them, because that's what their IDE looks like, and it's really difficult to take all the complexities of a distributed architecture and distill it into a few wizards. you know. So we're constantly struggling with the education part and trying to encapsulate as much best practice as we can into our tooling and make it as accessible to anybody that, you know, that we can possibly, you know, that we can possibly achieve. So, you know, that's we read the community loud and clear and trying to provide the best experience possible.
Cool. Well, we're up against our time here, so I want to thank all of you guys for participating as part of this. Michael will be sending you a fake beard for the next time we do one of these, because it's challenged. And I want to thank all of the attendees for spending your lunch hour, at least lunch here on the West Coast, or else you're skipping that afternoon meeting, which I'm sure was a real sacrifice for some of you, to spend time with us. And I want to say farewell from Seattle and give our panelists a chance to wave goodbye.